All right. So for the next problem on the review, this is 5.6. The problem says the effectiveness of solar energy. Let's fix that. Of solar energy heating units depends on the amount of radiation available from the sun. During a typical October, daily total solar radiation in Tampa, Florida, approximately follows the following probability density function PDF in hundreds of calories. Remember, this X is in hundreds of calories, and it's given by this here. And we want to find the probability that solar radiation will exceed 400 calories on a typical October day. So remember, this is in hundreds of calories, so we're looking for the probability that X will exceed, so it's greater than 400 calories in hundreds of calories, though, so this is 0.4. Is that right? No, sorry. Will exceed 4. Sorry, there's no point there. Right, that makes more sense. So what do we want to do? We want to integrate from 4 to infinity f of x dx. But again, in our case, we only have non-zero values for our probability density function when x is between 2 and 6. So this is going to become the integral from 4 to 6. And then we have 3 over 32 times x minus 2 times 6 minus x dx. So let's pull out this constant, and then we can FOIL this. So I think that's the way to proceed. So we pull out the constant of 3 over 32. And now we have the integral from 4 to 6, and let's FOIL this out. So the x terms, we're going to have minus x, the x squared terms, we're going to have minus x squared. The middle terms, what are we going to have? We're going to have plus 2x, and then plus 6x, so that's plus 8x. And then the other terms, we're going to have minus 12. This is seeming a little familiar, like we did in class, but oh well. That's okay. It's still good practice, I guess, so whatever. Anyways, this is going to be equal to now 3 over 32. And then we want to integrate this, so each term, right, we're using the power rule, I guess. So this is minus, we're going to add 1, so x cubed over 3, the new power, plus 8. Again, we add 1, so 8x squared over the new power of 2, and then minus 12x. And we're evaluating this from 4 to 6. So again, what do we want to do? We want to plug in the top value. So we want to plug in 6 and subtract off plugging in 4. So this is going to be minus 6 cubed over 3 plus, now this is going to be 4 times 6 squared minus 12 times 6. And this is going to be minus, now we plug in 4. So this is minus 4 cubed over 3 plus 8, so plus 4 times 4 squared minus 12 times 4. So let's plug that into our calculator here. So this is going to be 3, so I guess I'll do it all at once. So 3 over 32 times, in parentheses, minus 6 cubed. I think that minus will stay now, over 3 plus 4 times 6 squared minus 12 times 6. and then we're subtracting negative 4 cubed over 3 plus 4 times 4 squared minus 12 times 4. That cannot be correct. So what is going on here? Let's see. Because we want this to be a probability, right? So it has to be between 0 and 1 is the point. So let's see, x cubed over 3, 8x squared over 2 minus 12x. Minus x squared minus 12. So plus 2x, what is this, plus 8x, that looks good. So let's do these terms individually. So let's see if this is what we think it is. Yeah, it is. So let's do this term here. So this is minus 6 cubed over 3 plus 4 times 6 squared minus 12 times 6. Is this really 0? I'm getting this is 0. Sure. So 6 times 2. Okay, that's okay. 6 cubed over 3 plus 4 times 6 squared is 12 times 6. Yeah, that's what I'm getting. And then this term, we have minus 4 cubed over 3 plus 4 cubed minus 12 times 4. So what is that? This is minus 16 over 3. So I'm not sure where I made a mistake, but this looks like it's going to work out now. Yeah, it does. So now we have 3 over 32 times minus 16 over 3. So the 3's are cancelled. We get exactly 16 over 32, which is 1/2. I should have been able to do that in my head, but that's okay. So there you go. Sorry that took a little longer, but what else?